All right, students. So I'm going to go over the background introduction for the osmosis lab, and we're going to walk ourselves through kind of the experimental setup, and then we will look at how to set up the experiment. So quick reminder, definition of osmosis. Osmosis is the diffusion of water across a semi-permeable membrane from high concentration to low concentration. Another way to think of this is from a high percent of water to a low percentage of water. Or the way that I think of it is that water moves from wet to dry. This is passive transport, which means no energy is involved. And so the goal of this lab is basically to make hypertonic, isotonic, and hypotonic solutions to put our sample into, whether it's a potato or an egg. And we're going to both visualize osmosis and try to kind of determine a range for the concentration of water in an egg or a potato. So our experimental setup here, the independent variable is going to be the different percentages of water in the solutions that we put our egg in. I'm just going to say egg, even though it's egg or potato. So the concentration of water in the solutions. That's what you guys are going to have to make different at the beginning. The dependent variable, what we're going to be measuring is the size of the change. Really, it's the change in size of the egg or potato. Really, it's the volume. And our constants, also known as controlled variables, should really be everything except for the concentration of water. So the temperature in your room is going to be the same for all of them. The starting size of your egg or potato should be about the same. The length of time they're going to be left in the solutions should all be the same. The size of the container they're put in. The amount of solution they're each in. And basically everything else other than your independent variable should be the same. Our control group is kind of the isotonic solution, the one where we do not expect any change in volume. And then we can use that to compare the other two samples to see what percentage of water is in our isotonic solution and how that affects whether the egg swells or not. So at this point, we're going to try to figure out what we can use for our different solutions. And so I'm just going to kind of visualize with you here. These would be our cups, and we're going to have 3 of them. With our egg or potato. And so let's say if we want this one to be our hypertonic solution, this one's going to be isotonic, and this one is going to be hypotonic. So the way that I remember this, hypertonic solutions, the water is going to exit the cell and the cell is going to shrivel. And so our prediction or our hypothesis, if we do our hypertonic solution correctly, is that water is going to leave and the cell will shrivel or shrink. And how do we figure out what to put in there? Well, if the water moves from, we said the water moves from wet to dry, or from high percentage of water to low percentage of water, then that means that this needs to be wet and that needs to be dry, or this needs to have inside the egg needs to have more water than outside the egg. And so we don't know the exact percentage of water inside the egg, X% of water in the egg. And basically what you need to try to do to make it shrivel is get a solution outside the egg that is very concentrated, has a pretty low percentage of water, so that way, even if we don't know the exact percentage, it's definitely less water outside in our solution than there is inside the egg. So this needs to be a really low percentage of water or a outside. And so options that I would recommend, you could just mix up, like you can use salt or sugar. It doesn't really matter. You can use both of them. You could mix them up and just see the maximum amount that you can dissolve in water. I would get, warm water, put as much salt and as much sugar in as you can dissolve in there, and try to get it as concentrated as possible is one option. Or you could also, if you happen to have corn syrup is a really low percentage of water. It's mostly sugar, but there is some water in it. So it's a really high percentage of sugar, low water, and it will pull water out of the egg. Or you could also use like pancake syrup, maple syrup. It can't be, I don't know if it can be sugar-free. Maybe if it still has a low percentage of water. But if you have like maple syrup or corn syrup, you can put one of the eggs inside of that. Or you can just make your own with water and salt, or water and sugar, something that has a large amount of water and salt and a smaller amount of water. You still want it to be a liquid. So that's something you're going to play around with a little bit. Over here for hypotonic, we're going to have the opposite. We want the water to go into the cell, and the cell should expand or swell. And so again, we still don't know what percentage of water is inside the egg, but we need the outside of the egg to be wet and the inside of the egg to be dry, or the outside to have a high percentage of water and the inside to have a lower percentage of water. And so the easiest way to do that is just to go all the way to the extreme. And if we put 100% water outside of the egg, then that should definitely be higher than whatever's inside the egg, and the water should go inside. So for your hypotonic solution, you're just going to put pure water outside the egg, and that should cause it to swell. And then the isotonic solution, if we do it right, we should expect no change in size. And we want to have the same percentage of water on the inside and the outside. So we want equal percent. So this is Y% of water inside, Y% of water outside, the same percentage of water. Water will still move in and out, but it will move in and out at the same rate. And so there won't be any change in size of the cell. There won't be any change in percentage of water. This one is a little bit of a guessing game. So you have a couple of choices. If you want to do background research and try to find out what the actual concentration of solutes in an egg is and try to match it, you can do that. Or you can just, I would make a guess maybe around 10 to 20% of solutes. Might not be perfect. We're going to get as close as we can. And so if you're going to do, let's say that I'm going to do maybe 15% or 10 to 20% of salt or sugar on the outside, and then 85% of water. It's actually probably a lot easier to do 10 and 90. I'm not sure, that won't still swell, but that's okay. You guys can try 10 and or 20 and 80 or something else. And if I want to do 10% salt, sugar, 90% water, what I would recommend is using measuring cups. And maybe, let's say if you do, it's going to depend on how big your cups are so that you have enough liquid to cover the egg. And so let's say if you had, 1 tablespoon of salt and 9 tablespoons of water is probably not enough, but you can use that kind of a ratio to try to make your solution, even just using tablespoons or measuring cups. So I'm going to try to do maybe a 1/4 cup of salt, and then 9 times a 1/4 cup of water. And let's see if we calculate that out. 9 times a 1/4 cup of water is 9/4, which simplifies to 4 plus 1/4 is 2 1/4 cups. So I'm going to put, for my isotonic solution test, I'm going to put 2 1/4 cups of water. That's a lot of water. And a 1/4 cup of salt. So actually I'm not going to do that because that's too much. So I'm going to cut both of those in half. So maybe I'm going to do 1/8 of a cup of salt. And that would mean 1 1/8 cups of water. And again, it doesn't have to be perfect. We're not in the lab doing, medical research. We're just trying to get as close as we can to demonstrating the different possibilities for osmosis. So that's our background, our independent variable, concentration of water in the solutions. Our dependent variable, we're looking for if there's a change in size in our substance, the egg or the potato. We have a bunch of constants, everything other than the concentration of water, ideally. One of the eggs we're going to put in pure water to try to make it swell in our hypotonic solution. One of our eggs we're going to put in either water that we put a lot of salt and sugar in to try to make it a really low percentage of water, or we can also use corn syrup or maple syrup or something like that if we have it. Maybe like chocolate syrup even, I'm not sure. And then isotonic, we're going to do around 10% salt, sugar to 90% water. You can change that to 2080 if you want. 2080, I believe, would be making it 1 cup water and a quarter cup salt. So that's another option for you. Okay, that's our background. Let's go get set up for getting our lab started.